All right, looks like we have everyone. Good morning and welcome to Jamesway's Webinar Wednesdays. As usual, your control panel is in the upper left corner of your screen. It has a raised hand button there. The Q&A button, please use that to enter any questions that you would like to ask Dr. Bramwell and myself. There's also a chat button. You can use that to send us messages. And then you have an audio video options button that you can use if your audio needs a little tuning there. This week we're doing something a little bit different. I think the way our marketing girls have put the spin on it is we're turning the tables this week. And as I am not in the host chair, I'm actually going to be the topic speaker this week. And Dr. Bramwell is going to be fielding your questions, adding some of his own, and in general making me a little nervous here.
I'll do my best to fill your shoes here.
Yeah. So we'll go ahead and get started. Now, just as a disclaimer, this isn't the usual HVAC presentation that you guys may have seen from myself or some of the others in our group, some of our sales team. This is something all new, and it's really centered around building a hatchery, designing a hatchery, and why having the hatchery professionals do your design is more important than having a local contractor and how those things can go wrong or right. So, where's my show? There we go. So here at Jamesway, you know we are your worry-free incubator company, and we're going to be going over our hatchery HVAC. So just to start, some of you have been in the industry for a long time. You may remember that there was a lot of publications and a lot of rules out there, like every Jamesway multi-stage needs, I think it was 2 tons of cooling. And that rule was being applied whether you were in Alabama, whether you were in St. Petersburg, whether you were, in Lagos, Nigeria, or if you were at the North Pole, frankly. And the reality is that that isn't how HVAC works. The climate in all these different areas is very different. And so you may still hear those rules. I even heard those rules for our Jamesway Platinum machines. So let's get that out of the way. Those rules do not apply. Those rules generally were generated for Alabama as the sort of test site. So if your climate does not match Alabama's, those requirements do not match your life. So don't go there and don't believe them. So what is HVAC for our European friends? You guys would all call it ventilation. But it is the combination of air through ventilation, cooling through water and air, heating through the water and air, and humidity or dehumidification, which is also through the ventilation system. So what is the role of HVAC? Why is it important? So HVAC provides optimal operating conditions for the incubators. Your ventilation is the fuel for your incubators. Just like if you have a sports car, you have to put in some premium gasoline to get the optimum performance of your sports car. It's the same thing with the incubators. You give it good fuel, good chilled water, good hot water, and good air, you're going to have great chicks. If any of those things is suboptimal, you're now going to be sacrificing hatch and sacrificing chick quality. And I'm sure you've seen that.
Yeah, absolutely.
So ventilation, how does that work? Basically what we're looking at is the room in front of the machines. We have fresh air coming in to satisfy the oxygen needs of the eggs, which is either heated or cooled. We're adding or removing humidity. There is heat off the front of the incubators and hatchers, heat gain to the room. And then we have the exhaust air off the machines. And this is what we need to balance in HVAC in order to make sure that your room is operating perfectly at all times. So here are your optimum conditions, and if anyone needs a copy of the PDF with the information on this, I can send that to anyone. You just email me, webinars@jamesway.com. And this is for platinums, but essentially on a platinum, we're looking for a 75 degrees Fahrenheit or 24 degrees Celsius room at about 45% relative humidity. The fresh air per cabinet is going to vary, and also the pressure in the room and the pressure in the exhaust plenum is going to vary. based on the size of your cabinet. Obviously, the bigger cabinets need more air. They have more chicks. They need more oxygen. So if we go to single-stage ventilation, our single-stage machines here at Jamesway use a combination of air and water for cooling and heating. So we would like to say that air is about 30% of the cooling in your cabinet, even though the air is actually there for oxygen. And then the chilled water in your system is providing about 70% of your cooling. What this means is that compared to multi-stage, you require smaller HVAC equipment because a multi-stage machine would be 100% air cooled as it has no chilled water coils. But you do require a boiler and chiller in a single stage system. So there is some additional components. For multi-stage machines, like I said, we're using 100% fresh air for our cooling, for our carbon dioxide control, for oxygen to the eggs, and therefore bigger HVAC equipment is needed. So what happens if your ventilation is right? If your ventilation is right, first of all, your room is stable. From there, that means that you're actually running more energy efficient. Your incubators and hatchers are happy, they're operating smoothly, your hatch is improving, your chick quality is great. What happens when your ventilation is wrong? Exactly the opposite. You're seeing large temperature swings. 5 degrees Fahrenheit swings, plus or minus, humidity fluctuations. Maybe you're not controlling humidity at all. Maybe you're sitting at an 80% relative in that room. Or maybe it's winter and you're in Alberta and you're sitting at a 20% relative in that room. We have poor control of room pressure. That means that the machines are getting an inconsistent quantity of air. So the incubators and hatchers, you know, they have sophisticated control systems. So they're trying to compensate for the poor room conditions. Eventually they get to a point where they can't compensate well enough. Your hatch is compromised, your chick quality is compromised, things are not great. This is an example from the late 90s when our Guardian control system was improved. And this was a multi-stage hatchery. So here, and if you look, the pink is hatch of fertile, so that's kind of your best line. The new ventilation is installed here. So it looks like they have, what, an 87% hatch of fertile before. And right away for the subsequent months, they've jumped to over 90% hatch of fertile, except for this one little fertility dip where clearly something else was going on, where everything was affected. So that's why ventilation is important, right? That is 2, 3, 4% more birds out of your fertile eggs. And in general, we don't have, you know, concrete data on that, but the chick quality is better as well. So what is important in ventilation? There are 3 parameters. The first one is your airflow rate, which is also related to your pressure. It's controlled through fans and dampers. The next is the temperature. So either heated or air-conditioned chilled water coils, however you're controlling temperature, and then humidity. Humidifiers, AC units, dehumidification systems, whether that's on board on an AC unit or it's an inline electric duct heater in some areas of the world, or a hot water coil. All of those things contribute to dehumidification. So now, switching gears to the customer who is building a new hatchery, you need to design some HVAC. What do we need to know? What do you need to know? The first thing you need to know is detailed information on your location and the climate in that location. The other thing that I always like to know is, what are your future plans for expansion? If you're going to put in 6 P60s in a room and in the future expand to 9 P60s in that room, or in the future expand to 12 P60s in that room, I'm going to design the HVAC differently because I always want the rooftop units or the AHUs in the room to be the same size. So in that case, if you're only going to 9, I might give you the full HVAC at the beginning, if that's possible. If you're going to 12, you're just doubling what you have. So you would take the unit you already have and put another one on the second 6 in the room. So that's always important and always critical to look at. The other thing that can be important, and we have had some customers have issues here, is what utilities and services are available in your area. Not every hatchery in North America has three-phase power, and that actually limits the kind of equipment that I can select in your HVAC design. Also, if there's any limits on consumption, you may only be able to get so much gas per month or so much electricity per month. We've seen that issue in Russia before. And then what heating fuels do you have access to? Do you have natural gas? Do you have to truck in liquid propane? Is electric heat the right choice? Is there a local source of hot water that you can use for your heating, which is very common in Russia and also in a lot of cities near volcanic areas where they're actually harvesting heat off of that area to heat both the commercial and the residential buildings. So all of these things are important and relevant when we're going to make a design. So how do we calculate it? Basically, the first thing that we're doing is we're doing a heat gain loss analysis. This is the same thing that any HVAC contractor should be doing on a house, on a commercial building, on an industrial setting. And what we're looking at is first and foremost the fresh air needs. And the one main mistake that I see a lot is that local contractors think that the people in the room need oxygen, need fresh air, but don't realize that the incubators and hatchers also need fresh air, which is crucial. And in comparison, we would say for one person, you want somewhere between 20 and 40 CFM of fresh air. For one P120 incubator, we need 500 CFM of fresh air. So there's a huge difference there, and that can be one area where problems arise. Then is there a sun load or a heat load through the roof, the walls, windows, if there are any? Then we look at latent and sensible heating and cooling. So sensible heating and cooling is dry bulb cooling. So your temperature is changing on the dry bulb scale. Latent, for many of you who are used to multi-stage machines, that's wet bulb cooling. So that includes changing the amount of moisture that is actually in the air, and therefore actually has something to do with dehumidification as well. And then is there any heat gain to the room from the equipment inside, from incubators, from hatchers, or from the birds, right? We're looking at 1 BTU heat production per chick in the chick room. So 500,000 chicks, that adds up to a lot of heat very quickly. And then other specific climate data, weather events, things that may not be apparent right away if you're not from the area. So how are we different from industrial HVAC? Basically, the part that's being missed is that incubators and hatchers are containing live animals. The eggs are alive. The eggs are actually breathing, right? They're undergoing an exchange with the environment around them. So they're producing carbon dioxide. We need to supply oxygen. And like I said, the human load on a room is almost inconsequential. Whether we have 4 people normally working in an incubator room or 6, that's not going to affect the design significantly, because the number of incubators and the amount of air they're using is going to cause more of an effect. And it's the same thing in a chick room. We are looking at, if you are not very automated and you do have a lot of staff in your chick room, 20, 30, 40, then we start to see an effect. But if you're running with 10 or 12 or 8 or 4, there's not a huge difference there compared to the number of chicks in the room. So other differences, some HVAC contractors may use a rule that you need so many CFM of fresh air per square foot or so many tons of cooling per square foot for that geographic area. That doesn't work either, especially because an incubator or a hatcher hallway is a very small square footage of area, but it has a lot of machines off of it that have a high fresh air demand. So that's the key there. So if we were looking at a square foot ventilation, ASHRAE, the American Society of Refrigeration and Heating Engineers, would suggest that, okay, maybe a quarter of a CFM per square foot. So our hallway with 6 P120s on each side, so 12 total, needs 300 CFM. But our P120s, like I said, need 500 CFM each. So that's actually 6,000 CFM fresh air required. And this, unfortunately, is where some hatcheries get into trouble, that they use some local guy who doesn't understand and doesn't ask the right questions. And so they end up with ventilation designed for 300 CFM of fresh air versus 6,000. So what happens if that fresh air is calculated incorrectly? The first problem is your fanning, your rooftop unit or your air handler is not big enough. So you're not going to get enough air. But then also there are smaller effects, like you're not going to have enough heating, you're not going to have enough cooling. If it's sized wrong, you could have freeze up of your HVAC units. Your HVAC unit, if it's kind of marginally sized, is going to run for very long cycles. It's going to have excessive wear and tear, so you're going to have a decreased usage life. The main thing we see is we cannot achieve and maintain pressures at full capacity, and a lot of times you don't see that right away because a lot of hatcheries start up slowly. They don't start up, setting all their machines at once, so it may run fine for the first 6 months or the first year, and then they're wondering what happens. And the machines are starving for air, so that means our chicks and our eggs are starving for air. So that affects our hatch. So when we're talking about your location, what matters? Outside of, the basic, is it a hotter or a colder location? Elevation matters, proximity to seawater, your winter design temperatures, your summer design temperatures, humidity year-round, and then specific climactic or weather events. And the biggest one there that we're concerned with is countries in a monsoon area. And from that, we can use something called a Köppen classification to help us learn about the climate in the area. So elevation. If a hatchery is located over 1,600 feet above sea level, the reduced density of air must be considered. So we actually require more fresh air per cabinet because there's less oxygen in 1 cubic foot of air than there would be at sea level. And in some cases, if you're located at very high elevations, your mechanical refrigeration systems, so your rooftops, your chillers, actually need to be designed with different components in them, also maybe your gas or propane burners, to again compensate for the fact that there will be less molecules in a given volume. Proximity to seawater. Our concern there, of course, is corrosion. And salty sea air can be a factor up to 100 kilometers inland. We have very high volumes of air moving in a hatchery, and those are going through metal heat exchangers, and that's what we don't want to corrode. If you're located in an area like that, what you really want to look for is getting coil coatings to protect your heating coils and your cooling coils. You also want to make sure your HVAC unit has a paint on the outside. It's not a bare metal unit. And then also consider different materials. Does it make sense to go on that upgrade to the stainless steel heating coils instead of a copper heating coil? So this is a nice global map that sort of shows you where there is salt deposits inland, and therefore we can assume that salt sea air has an effect on HVAC. And as you can see down here, that is really most of Europe. And most of the coast. It kind of looks like there is no data for Canada, but you can sort of assume that it would be very similar to the 100-kilometer swath that you can see through the United States, and the same thing for Africa. We don't have the data, but I mean it's a fairly standard bandwidth across all of the world, so it would be very similar. Then your winter design temperatures. The first thing you need to make sure someone is looking at is what is the difference between the average annual low temperature and the 5-year or 10-year low. Because if every 5 years you're going to have a day or 2 days or 3 days or a week where you have a shortage of heating, that could cause a problem for you. So you may want to bump up your heating size, especially if you're kind of on the edge between two sizes, to make sure that you cover that. One of the other problems we have is that because we're running our incubator and hatchery rooms at a higher relative humidity than you would run an industrial or a commercial or even a residential building, that humid air goes up into the rooftop and it mixes with the cold outside air. And sometimes we drop below dew point, so that means that dew or condensation is formed. And that forms, as you can see here, right on the coils. So in Russia, in Canada, in the northern US, you may know of a hatchery, it may have been your hatchery, that has actually had a rooftop freeze solid. No air would pass through because the entire thing freezes from this combination of mixed air. So that's another thing that we here at Jamesway consider that is sort of unique compared to what you see in most other industries. And it is very significant. Basically, rule of thumb is if your winter design temperature is below 8 degrees Fahrenheit, I'm sorry, I don't know what that is in Celsius, then you are in the area where you're of concern. And of course, the colder it gets, the more concern that we have. The other concern with your winter temperatures is your water systems. You require freeze protection if your temperatures drop below 40 degrees Fahrenheit, drop below 0 degrees Celsius, through the use of glycol, whether that's a food grade ethylene or propylene glycol, that's really up to you as far as what you use, but you need a glycol in the system, and you need to have it actually freeze tested by the contractor that's adding it, and it needs to be checked regularly, because if you have a metering valve that's adding fresh, city water into your water tank when the level gets a little bit low, that's going to be diluting your glycol and you can lose your freeze protection. We've actually had that happen here in Canada, and the customer's fluid cooler, they lost power over the weekend, froze up, blew all the coils on it. So you need to watch for that. And then you also have, in these situations, the ability to use a fluid cooler for free cooling. So what that does is it uses that cold outside air instead of using a refrigeration cycle to actually chill your chilled water. It's a big energy savings. And not only is it an energy savings, but it actually increases the lifespan of your chiller because you're not forcing it to come on for very short cycles throughout the winter. What about snow load? This is one thing that gets missed sometimes. And you see this poor fellow here, kind of even looks like he might be on a hatchery, is having to dig that rooftop out of the snow. So we always need to consider, how high is the snow going to get? Is it going to, pile in one corner? We have one hatchery here in Ontario that the way their roofs are, it's very difficult for them to get up and service their units. And your servicing of your units, your preventative maintenance, changing the filters every hatch doesn't stop just because it snowed, and it doesn't stop just because it's winter. So we need to make sure that those are highly accessible. We have a client in Minnesota who has all their equipment basically on stands like this one here in the bottom right, just so that they are high enough out of the snow. And it's not fun to work on them in the wind and a blizzard, and it was not fun at all, but at least they can get at them, right? Yeah. So then if we're looking at summer design temperatures, we have the same concern here. If your 5 or 10 year design is significantly higher than the 0.4% design value, and this is all coming from ASHRAE data is typically what I use, then you're gonna end up having insufficient cooling. And a lot of customers have actually been talking about global warming. We can't project what the temperature rise in your specific location is going to be, but I think it's a safe bet that if you're looking at, your 5 year or your 10 year, and they're, more than 10 degrees Fahrenheit higher than your normal design temperature, then you should consider using those. Because we do know that global warming is a fact, that there is increases in average temperature around the globe. And what you don't want to do, because this equipment should last you 15 years or more, you don't want to have to replace it or augment it because of poor design in the beginning. The other problem is summer design doesn't tell us the whole story. So we're going to use Beijing as an example here. Beijing has a 94.7 degree Fahrenheit summer design temperature, 32% relative humidity. That tells me they don't need dehumidification. That's similar weather to areas like New York City, Chicago, Toronto. You maybe have a few weeks in the summer where it gets pretty humid, but as a whole, on their hottest days, it wouldn't be humid enough to require dehumidification. So then if we go, and these charts here are available on Wikipedia for most major and a lot of minor cities around the world. You'll see in the middle here, July and August, our average high temperature is looking at like 87, 85 degrees Fahrenheit, but our relative humidity numbers down here in the blue band are sitting at 75, 77%. And this is, a monsoon season, a rainy season. And the problem here is that the temperature isn't super high, so our AC unit isn't running constantly, but our humidity is high. So the AC unit on its own is not enough to lower the relative humidity during this situation. So they need dehumidification because of that. So, rule of thumb, start right there. If you have monsoon or a rainy season, you require dehumidification for that season. But what is the big deal with humidity anyways? The water content of the air actually changes the heat carrying capacity of the air. And our feeling of comfort is affected by both the dry bulb and the humidity. And you hear that a lot here. People will say, I went to Arizona, it was so hot, but it was so dry and I was so comfortable. Where, they're in New York, they're in Toronto, they're in Chicago during our very humid weeks that aren't nearly as hot as Arizona. But the humidity makes it feel so much hotter, right? Because we can't sweat. And then the other thing is that our moisture loss on our egg is super important, right? We've talked about that with Dr. Bramwell. We've talked about that with Philip. Lynette's mentioned it. Jerry's mentioned it. Bill's mentioned it. Moisture loss is so important. So if your air is too humid, we're not going to be able to release enough moisture from that egg. If your air is super dry, you're in Alberta in the middle of winter, you're going to be pulling too much moisture out of those eggs. So that's why humidity control is important. This is some data on a multi-stage machine. So based on the percent relative humidity in the room, this is how much fresh air that multi-stage machine wants. Because remember, they're 100% air cooled. So at 50% humidity in this test, they were below 200 CFM. By the time the room hit 80%, we doubled to 400 CFM. And at 90%, we're at 850 CFM. So that's why humidity is so important, because it really is going to change, especially in your multi-stage machines, how your machine is going to react. Also very important in your platinums. And then what about special climate considerations? So like we talked about, monsoon, a moderate rainy season, very important. Other concerns are very cold winters, like we said, for freeze up, for things like that. Dry winter areas, that would be the prairies in Canada, where your relative humidity is very, very low during the winter, and also you're using a lot of heating, so your rooms are going to be very dry. In those areas, it's absolutely essential to have humidification in your room so that you can get up to that 45% target that we have for platinums. And then areas that have high humidity year-round. If you are heating and still need dehumidification, that's another consideration. And then other special weather. Do you have sandstorms, so you need sand protection? Are there hurricanes? Are there tornadoes? Things like that. So from that, one of the things we can use is the Köppen classification. This is a very detailed climate typing, so it looks at not only the maxes and the mins of the temperature and humidity, but it also looks at other factors that occur. And this classification can trigger us in the HVAC world for some important concerns. So if the classification was a tropical rainforest, a tropical monsoon, those would be customers that you definitely need dehumidification. If you get the cold desert climate, that's the prairies, right? It's incredibly cold and incredibly dry. So these give us very quick tips, and the Köppen classification is on the Wikipedia for most major cities, minor cities, and most townships around the world. So you can find that as a very quick trigger as to what special conditions are happening there. So if we go back to Beijing, the Köppen classification there is a humid continental climate. And then when you read the description, because it has a monsoon and rainy season. So there you have that clue right away that isn't apparent when you're looking at the data from ASHRAE or any of the other heating or refrigeration engineer organizations around the world. Other clues, Saudi Arabia is my favorite example for this one. If you look at Google Image or Google Earth for the city or the region, you can actually get photos of the landscapes that people have put up while they've been there and geotagged, and that gives you a quick idea. So if we look at Riyadh, Jeddah, these areas are very hot. Riyadh very dry because it's inland. Jeddah is a little more humid because it is coastal. So there we have our sea spray concern. But then there's the Asir region in Saudi, and this region is green. It has moderate temperatures. It's a little drier than Toronto, than New York, than Chicago would be, but it doesn't get over 100 degrees Fahrenheit there. It generally doesn't get over 90 degrees Fahrenheit there. And so, the photo on the bottom is from the Asir region, and the photo on the top is, from the middle of the Arabian desert. And so right away, you can see from that photo, there's a lot of greenery, and this is wild greenery, not cultivated in town, right? So those are more clues we can always be looking for. And then when we get to special weather, an exceptionally relevant topic right now. So what's the most important thing to look at? The most important thing to look at is protection from damage, because we want you to be able to stay running or get back up and running as quickly as possible. So one thing is there is hurricane strapping that helps hold your rooftop to the curb even stronger. I think there's also like a hurricane curb you can get. And then the location of mounting. Don't ground mount your HVAC if you're in a high flood area. Before a major storm comes through, have your maintenance guy, have somebody go out and check, is there any debris on the roof that they've left up there when they were fixing something that could become a projectile and damage your equipment? Are there any trees or poles or something that could fall in high winds? And shut down and cover any unit that you can for additional protection. Don't forget about your accessory equipment, your fans, everything should be protected if you can. And always discuss with your HVAC provider, your local contractors, if there are any specific features that are commonly used in your area. This is where your local guy is a huge benefit. He's going to be installing your machines, and he should know, okay, typically we're putting in this, we're putting in seismic considerations in the rooftops because of the earthquake risk here, that sort of stuff. And don't forget about those generators. Make sure that your generators are tested. Make sure that your generators are also well protected. Look for that debris, look for trees, that sort of stuff that could take you down, because we know our setters and hatchers keep running. Some questions there?
Yes, a couple of questions here. Talking about the HVAC and Jamesway in particular, does Jamesway provide the design services for HVAC?
We do. So we can run it a couple of different ways. We can design and supply the equipment for local installation, or we can just design the equipment. We can also just supply the controls along with the design if that's what you need. So we have a variety of options. We've also looked at designs provided by customers, talked to local contractors to help them understand what they need to be doing correctly.
And that would apply for both new installations or construction and existing. So if somebody has an existing hatchery, then that opportunity still exists?
Yeah, for sure. And definitely if you have an existing hatchery, we know that the average life of machines is longer than the average life of HVAC units. So at some point you're going to need to be replacing that HVAC maybe before you replace your incubators and hatchers. It's always a good idea to, have that checked with us rather than putting in what you put in back in the 70s or the 80s. Don't just put in the same size unit because, like we talked about, climate is probably changing. And so that's a concern there. Also, if you're putting it in a multi-stage room and you think that you want to go platinum in the next 5 years, let's make sure that whatever we're putting in will service your multi-stage today and your platinums tomorrow. The worst thing that could happen would be that you put in something today that isn't suitable for what you need tomorrow.
Okay, that was one of the questions I had too, was, a lot of people in the industry are very familiar with multi-stage, and they kind of know that like the back of their hand. So when they move to single stage in a new existing unit or modify their existing hatchery, I mean, what generalities as far as the change in functioning of the HVAC unit should they expect?
So typically your multi-stage unit is going to be oversized for your platinums. In most areas, that's not going to cause a problem. It just means that your dampers aren't going to be open as wide as they are with your multi-stage if you're running an economizer system. The big thing that we do see when customers are going multi-stage to single stage is you're going to need to probably reroute your ducting. You're going to need to fix your floors, and then you need to add that boiler and chiller system. So those are the major concerns. You also may need to look at, if you didn't have dehumidification, you may need to look at dehumidification now. So that can be a challenge because dehumidification, if we're looking at a hot gas reheat style, can't be retrofitted onto your Aeon or your Train or your Carrier rooftop, right? That has to be put on at time of order. And that's why if you think that, okay, I probably am going to put in platinums in the next 5 to 10 years, it's worth having that analysis and maybe adding, the dehumidification now, even if you don't use it for your multis, but because your singles will be happy when they get it.
So if somebody's going from a multi-stage to a single stage and has an existing HVAC system that's working right, they wouldn't necessarily have to replace that because it's more than what they need. But with the other things, changes and added, would you recommend probably to go ahead and redo the whole system? Or maybe it depends on the age of it, or...
Yeah, it's going to depend on the age of the unit, your location, the sizing of the unit. There's so many factors that we can look at. Sometimes we're going from multi to single stage and we can actually get a higher capacity of eggs in the room with single stage. In that case, your HVAC unit may not be oversized anymore. It may be perfectly sized. But dehumidification is the biggest concern. But we can also do kind of cheap, costly to operate, but cheap retrofits. If you need to get through the next 5 years with that unit before you replace it, we can add something like an electric duct heater to provide the reheat that you need for dehumidification, as long as you have that excess cooling capacity so that we can subcool the air and then heat it back up to our room temp.
Okay. So would you ever take into consideration like the operations of a hatchery? For instance, maybe some of the smaller hatcheries might only hatch twice a week. Instead of looking at just the egg capacity of the hatchery, some might hatch twice a week, most probably 4 times a week, but there may be some that are 6 times a week. Would that change the needs depending on how the hatchery is used?
That is huge, right? So, there are HVAC units out there that can do 1 million eggs per week. Well, 1 million eggs per week hatched twice a week is a lot different than 1 million eggs per week hatched 6 times a week. Your chick room capacity is going to be vastly different, of course, but also because there's, a distributed effect in your chiller sizing, your chiller size for the same number of machines hatching 6 days a week is somewhat smaller than hatching 2 days a week because you have a more distributed load. You don't have all your hatchers at day 21 at the same time. And it's the same thing with species, right? You don't need quite as much chiller if you're running turkeys because that heat is distributed over a longer period of time.
Yeah, that was one of the other questions as far as turkeys or ducks or anything like that. How much difference is there?
In terms of the incubators and hatchers, I have a different set of specs in terms of fresh air that I'm using for turkeys, ducks, or geese. But that's the main difference that we have there. If you're looking at your chick room, your poult room, your duckling room, your gosling room, that's where the big difference is because turkeys, ducks, and geese, they're bigger birds. They're producing more heat. They need more air than a chick. So my numbers of 1 BTU per chick are not valid to use for turkeys, ducks, or geese. We're looking at more like, I think, 1.5 to 2 each bird, right? So that's the major change there.
Okay. Another question. What is Jamesway's current thinking on recirculating air type, HU or 100% outside air supply units? Is one preferred over the other?
I knew someone was going to ask that question. So
Must have been a good question.
It's a good question. And I mean, it's the question of the past couple of years in the industry. Proponents for 100% fresh air like it because it is more biosecure. And I can't really disagree with it, but at the same time, I can say that I can give you, in either situation, with the right treatments, you can get cleaner air out of that supply grill on a recirculated or 100% fresh air unit than what you're bringing in from outside, right? There's UV, there's HEPA, there's all sorts of filtration that we can do, just like we can clean our water to cleaner than what it's coming in. So in that case, if biosecurity is really what you're concerned about, you probably should be also looking at what additional air treatments do I want to look at? Do I want to look at hydrogen peroxide treatments? Do I want to look at UV filters? Do I want to look at HEPA, that sort of stuff? The problem for me with 100% fresh air is that single pass dehumidification is not always possible with 100% fresh air. And in a lot of the areas that are favoring 100% fresh air supply, like in Asia, to me, the fact that you cannot get down to that 45% relative humidity with one pass of the air through the rooftop unit or the air handler or whatever you're using for the 100% fresh air supply causes a problem, right? If you can't get that dehumidified air, you might need more air. And if your air handler hasn't been sized to take care of that extra air that you may need, that's going to be another problem. At the same time, in my work with 100% fresh air, I found that, temperature, unless you're using chilled water and hot water coils, your temperature control is not as great as we can do with recirculation. And then also your pressure control can be not as great. So those are some other considerations there as far as why you would not use it. That being said, Jamesway can and does provide solutions either way. If you like 100% fresh air, we understand the need for that. If you prefer recirculated air, we understand the needs for that. One final problem with it is if your hatchery is setting room 1 in week 1, room 2 in week 2, and room 3 in week 3, 100% fresh air will not do it for you. And the reason for that is in week 1, in each of those rooms, 0 to 10 days, your dampers are closed. You have no fresh air requirement into the room. Therefore, you have no air requirement into the room in a 100% fresh air situation. And what happens then is the heat off the incubators and hatchers heats the room up. And we've seen rooms hit over 90 degrees Fahrenheit just from the heat off the incubators and hatchers heating the room or just the incubators in that 0 to 10 day period. The one thing you can do to combat that is then you put an exhaust fan so that there's a constant amount of air flowing through the room, but now you're dumping air that you just treated right out the back of the hatchery, right? Those are dollars flying out the back of the hatchery. So I hope that answers your question, but I am still a very strong proponent of recirculated air because of the stability and because it is something that will suit every climate. We can work with every climate there is. But I do understand the desire for 100% fresh air and the concept there. I just don't think that it necessarily is the best choice for everyone.
And that was a good point to bring up with the different rooms and settings, because we see that often is that they'll set a whole room at once if it's a smaller hallway or room or something.
Right.
So that's a good point to bring out about that, the needs for
and that often goes in hand with customers who are highly concerned about biosecurity, right? Because it makes sense to sort of pull one room all in the same week. Mm-hmm. So we see that in the hatcheries that are very biosecurity aware. And then their 100% fresh air system is just not working for them because their rooms are overheating. It's getting humid in front of the machines. It's just getting gross. So that's my soundbite on that.
So with this existing hatcheries, would Jamesway likely send somebody out to evaluate that? So we've got a hatchery that's been running and operating, may or may not put in new equipment, but if they're thinking of new equipment, it was Jamesway then have people that can come and evaluate that and say, this is what we think you need for the existing equipment or maybe for an expansion.
Yeah, we've done that. We also, we love photographs. We love if you have your as-built drawings from when your HVAC originally went in. I know that most hatcheries don't have those, but if you have those, and oftentimes our sales reps can look at what's going on in your room and really relay enough information back to us that we can sort of help you figure it out. But yeah, I've definitely done visits in the past with customers to check out what their new space is going to look like and what needs to be done there.
Okay, so what are either, as far as energy savings and stuff, a lot of people are concerned with that. Do you have any recommendations or expectations of a potential energy savings if, somebody's going in and wanting to really redo their HVAC system?
So if you are running Jamesway single stage, your single largest benefit to energy savings is to run a water-to-water heat recovery system. And the reason that I say that is a 365 days a year energy savings, financial savings. Many of our competitors, many local HVAC contractors look at our system and want to put in air-to-air heat exchange, or they want to put in a water-to-air heat exchange. And in all of those situations, you're really only getting the money out of that. You're really only getting the savings out of that when the conditions are right. So when the fresh air is the right temperature. And so that's not a 365 day a year savings, right? If you're using your chilled water to preheat your winter air before it goes into your air handler, which is a great idea, you still only have that savings, in the days when your fresh air is coming in, say below 0 degrees or whatever, whatever number it's been designed for. So I would just watch out for that. The other things are the use of a fluid cooler in the winter if you're a smaller hatchery who can't afford or isn't big enough for a good payback on that water-to-water heat recovery. Things like paying for the hot gas reheat in advance on your rooftop units. It's a much lower cost to run than any other way of dehumidifying the air. And really just having it designed right? The better your design is in the beginning in terms of the correct sizing, the correct airflow, the more energy efficient it's going to be, whether it's a traditional system, whether it's a 100% fresh air system, whether it's a highly sophisticated heat recovery integrated system, whether it's a, packaged all-in-one unit box. The quality and the energy savings there all has to come from the design stage. So making sure that the design is correct and the people understand incubation is really what's key to me.
Okay. You mentioned something a little while ago about the concern in hatcheries, obviously, for biosecurity and cleanliness. And we see that in hatcheries, clean up the hallways and machines and everything. As far as looking at parts of the hatchery that are unseen, your plenums, your ductwork channels, things like that, potential for bacteria, mold buildup, what are some solutions Jamesway might have or recommend to assist with that? Okay.
So the first, there's a lot of stuff there, right? There's a lot to unpack in this box. So the first thing is, or the first easy thing to look at when you're putting in HVAC is, do you want to try UV lights? Do you want to put in HEPA? That sort of stuff works. Then there are options of room treatment options. Some people have been using BioSentry 904 to sort of mist or fumigate their rooms. Of course, there's our traditional fumigation that is even done in some rooms in some hatcheries. There is the dry hydrogen peroxide solution that's kind of being looked at University of Georgia right now that holds some definite promise there. So there's lots of choices there. One of the big things to me is your duct length. Often in these 100% fresh air systems, you have one giant duct and it runs the entire length of your hatchery, and there's all these branches off it and it goes to all your rooms, which is great until you get mold or bacteria or biofilm in that duct, right? And then when that happens, that entire duct needs to be ripped out and replaced. You can't clean biofilm off. It's basically over if you get a biofilm. So that's a big concern. The other concern is from that is that's a maintenance thing, right? You really should be cleaning out those ducts regularly. There should be a clean out every 10 feet, I think is what we recommend here at Jamesway. So someone needs to be going in regularly, maybe monthly, and cleaning those ducts and making sure there is no debris in there to prevent that. So that's a problem. Then we have the intake plenum solution. I don't know how many of you are highly familiar with that, but basically what that is we have our incubators, and they, instead of taking air off the hallway like we've been doing traditionally, you put a plenum, which is essentially a very large duct, and they pull the air off of that. So this plenum is pressurized. This solution can work nicely. It's a little more difficult to actually balance and maintain, and that's because the total volume of air we have there is very low, so it's not going to buffer changes in temperature and humidity and that sort of stuff very well. But the problem then becomes that space under the intake plenum, which is in front of the incubators. That space needs to be ventilated too. And if it's not ventilated, we have mold growth. We have, yeast. You can smell it. The area gets very warm and very hot, and I know you've seen that. And then that becomes a breeding ground for contamination. And you're driving your eggs on racks through this breeding ground for contamination, right? So it's great that your fresh air is coming in nice and clean, but you're driving them through a car wash of disgusting, basically. And that's going to lead to contamination. So if you are looking at that solution, and I know it's proposed a lot on a lot of sites, it's very popular in Europe, and in Asia right now. The key is make sure that you're asking that question. How is the space in front of my incubators, how is the space in front of my hatchers also going to be controlled? Is it controlled separately? Do we have bleed through and exhaust? What are you doing there? Because if you're not doing anything, it's literally just going to be a ticking time bomb, unfortunately, for your facility.
Yeah, thank you. Good topic.
All
Good
right.
discussion. Yeah, I covered a lot of information there. I learned a lot with it. Hopefully everybody else did. Again, if you have any additional questions, you can send them on to Tori, and I'm sure she'll be glad to respond to them. If you have any final comments or words you want to say in wrapping this up,
Another one.
then go ahead. One more? Okay, one more. What do you recommend, AHU or RTU?
Okay, that is your choice. I like rooftops because I'm in North America and they're readily available and everyone here knows how to install and run them. The other thing I like about a rooftop is that your air conditioning, your cooling is on board, where with air handlers, if we're not talking split systems where you have a split condenser outside, but a chilled water air handler, you have a ton of plumbing you have to run to those air handlers. Usually you're running your hot water plumbing and your chilled water plumbing. So that's a high cost. But in terms of which one can be better for your room, which one controls better, there's no difference. If you have a good control system, if you have the Guardian control system that Jamesway offers here, and your air handler or rooftop is compatible with it, or we can make some modifications to do that, it'll be fine. As long as it's well controlled and well-sized air handler, rooftop unit, it really doesn't matter. There really just means to the same end.
And one final thing before we wrap up.
Okay.
What about biosecurity with a rooftop and air circulation? Any concerns or thoughts on that?
Okay, so the concern with recirculation is that we're going to be bringing back bad air and sending it back out again. in a rooftop, we're using one rooftop per room. So you're taking the bad air that the room has and sending it back to the room. So it's not like we're taking the transfer room with the exploders and dumping that air into the egg room and contaminating everybody else, right? That contaminated air is staying in the same location. So the recirculation isn't actually doing anything to distribute contamination around. All it's doing is better controlling your humidity, better controlling your temperature, and better controlling your pressure in that space. So not a huge concern from a biosecurity standpoint there, but if that is something you're worried about, there is all kinds of things you can put in a rooftop, right? There's all kinds of technology that you can use to clean that air so that it is cleaner than the air that is coming in from outside.
Okay. We have a couple more questions. I think you can respond to those later if you want to. We're about out of time. One last one. Does Jamesway provide building and HVAC or turnkey solutions for HVAC? Do they provide the whole package or?
We generally don't provide the whole package. It is something that we can help you work with. What we prefer to do and what I prefer to do is actually work with your contractors directly. A lot of times problems occur because the information is going from Jamesway to the customer to the contractor, and things are getting lost in translation, especially when the customer is not, an HVAC person, is not highly technical on that sort of stuff. So it's always better if your HVAC engineer here at Jamesway, your project manager, whether it's Tony, Ernesto, Oscar, or Vladimir, is talking directly with the contractors instead of talking to the customer and then the contractor, just because we don't want any confusion or any misconceptions that may happen and have happened that way before. So turnkey is something that we do a bit of, but at the same time, we can also, if you have a general contractor who's doing your building, we can work with them and we can work with all the sub-trades to make sure that they're installing everything perfectly and that your install will go very well. And we have a high track record of doing that on a lot of sites and a lot of success. So there you go.
Great.
All right. Thank you, everyone, for joining us this week. As always, email your questions, comments, concerns, or ideas for the next webinar to webinars@jamesway.com. You can check out what is coming up next at jamesway.com/webinar-Wednesdays. And thank you so much for joining me, and I hope that we will see you all soon.
Bye.